talk about the most important topic of determinant, that is properties of determinant. Properties of determinants. This is something like that. If you know the properties, you will have a better idea of solving determinant or finding the value of this thing or proving determinant into something. So let us talk about how determinant behaves. The first property we'll talk about, if the rows are converted into columns or columns are converted into rows, then its value remains unchanged. If rows are changed into columns and vice versa, then its value remains unchanged. Means whatever the value before changing the rows into column or column into rows, that will remain same. So for example, let us we have determinant 1 2 3 4 5 6 7 8 9. We evaluated it this 1 into, now I'm going to directly, because you are knowing the things now better, 1 and this leaving this thing outside, this will be 1 1 1 2 and 1 3. So here it will be positive, negative and positive, that you need to remember now. So 1 into 9 5 ja 45 minus 9 5 ja 45 minus 48, and then minus time 2 into 9 4 ja 36 and minus 7 6 ja 42, and then lastly plus 3 times 8 4 ja 32 8 4 ja 32 minus 7 5 ja 35. So let us evaluate it to 48 minus 45 minus 48 minus 3, and then minus 2 into minus 6, this minus 6, and plus 3 into minus 3. So its value is minus 3 plus 12 and minus 9. So we had done it previously also. Minus 12 plus 12 is equal to 0. Now let us change its this thing, what do you call this rows into columns. So let us change the changing rows into columns, that is, now I'm going to write it 1 2 3 downwards, 1 2 3 4 5 6 and 7 8 and 9. So this is a determinant, and now let us find out its value. 1 into, now leaving it this way, 9 5 ja 45 minus 48, then plus 4, sorry, minus 4 into 9 to the 18, 9 to the 18, and 8 3 the minus 24, and plus 7 at last, and then leaving this way, and then this 6 to the 12, 6 to the 12 minus 15. So this should be 45 minus 48 minus 3 minus 4 into 18 minus 24 minus 6 plus 7 into minus 3. So minus 3 plus 24 minus 21. So minus 3 minus 21 minus 24 plus 24 is equal to 0. So this this proves property 1, that any rows or all the rows of any determinant, if we change into columns, then its value, overall evaluation will remain unchanged. That whatever the value we got before changing it is same after changing it, after changing the rows, column or rows. So that you need to remember this. Now property number 2 is, if any two rows or any two columns are interchanged, then the value of new determinant will be minus time the old one. If any two rows or columns are interchanged, then the value of new determinant will be minus times the value of old determinant. What does it mean? That suppose we have this determinant, the old one, we have taken its value, that is something here, and if we interchange any two row or any two columns, then its value will be minus times determinant of A. That should be the rule number 2. What I mean to say here, for example, we have determinant A. Again we take the same example 1. This time let us write 2. Let we have determinant 2 0 4 3 minus 1 2 2 1 5. Suppose we have this determinant. Now just evaluate it. So 2 times R1, we are expanding through R1, so twice of this, leaving this way both, and then 1 into this one, and then minus time this, minus 5 into minus 1 into 5 minus 5, and then minus 2, then minus 0 into something, whatever, that is no need of writing anything here, because that will be 0 only, 0 into something, so that I am not going to write. But for your knowledge, this should be leaving, we should be leaving this column and this row, and then 0 into this 3 into 5 minus time 2 into 2, that we are not writing. So then plus 4 at last, then this way leaving these two vertical lines, then 3 into minus 1 3, and then minus into minus plus 2. So now 2 into minus 7 minus 0, and plus 3 plus 2 5. So minus 14 and plus 20 is equal to 6. Now same value, what I was telling you, that suppose we are changing its after interchanging R1 and R2, R1 will be written at the place of R2, and R2 will be written at the place of R1. Then let us see what happens. So what I'm going to do here, we are changing this, R1 will go up, R2 will come down. So we are writing first 3 minus 1 2, and then 2 0, and then 4, and then R3 remains as it is 5. Now let us evaluate it through R1. So 3 times, leaving this way, 0 into 5 0, minus 4, minus minus plus 1, because in the middle here the suffixes are 1 and 2, so 1 plus 2 means odd number, so it will come negative times, negative into negative positive. So 1 leaving this way, and then 2 into 5 10, and minus 4 to the 8, and then lastly plus 2 into 1 2, minus 2 into 0 0. So this is minus 4 into 3 minus 12, and then 10 minus 2 plus 2, and then minus 2, and then 2, and then 4. Minus 12 plus 6 is equal to minus times 6. So just look at here, this minus 6 and this plus 6. So what you can say, that this 6 is what? Determinant A. Determinant A is what? 6. So we are going to write determinant A is equal to minus times 6 is also nothing but determinant A. So determinant A. This is the rule number 2, property number 2, that if any two rows or any two columns are interchanged, then its value will be minus time this thing. Now here I would like to quote that you should not be confused between property number 1 and property number 2. In property number 1 we are talking about transpose. If you remember, we had studied transpose in matrix. So we are talking about transpose, means all the rows are converting, all the rows are converting into columns and columns into rows. But in this particular case, in property number 2, we are not changing all. We are changing any two row, maybe R1 into R2 or R2 into R3. Any two, whenever we are changing any two, minus will come out. Next time suppose we are changing, then again minus will come, that means plus. If we are changing R1 into R2 and R2 into R3, so then there will be positive sign only, because twice we are changing, so 2 times minus will come out. Similarly, if C1 is going to change into C2, C1 we are writing here and then C2 will replaced here. So then what will happen? This one minus will come out. Suppose again we are changing C2 into C3 and C3 into C2, and then again one more minus will come, then minus into minus plus. But if we are changing at once only, any two row, any two column, then minus will come out. That is the difference between the property number 1 and property number 2. Property number 3 is, if any two rows or any two columns are same, are identical, then overall the value of determinant is 0. If any two rows or columns are identical, then the value of that determinant is 0. What does it mean? For example, let us we have determinant 2, 4, 6, 7 minus 5 minus 8 and 2, 4, 6. As you can see, this R1 and R3 are identical. These are identical. So this property says its value must be equal to 0. Let us check it. Expanding through R1, twice of 2 times, leaving this way, minus 5, 6, minus 30 and minus plus 32, minus 4 into 6, 7 42 and plus 16, and at last plus 6 into 7 4 28 and plus 10. So this way, twice into twice, minus 4 into 58 and plus 6 into 38. Now 2 to the 4 minus then plus 6 is 48, 222. So what we are going to get? 4 plus 28, this minus 2, 3, 2 and plus these 2, 2, 3, 2. So cancel is equal to 0. So means the value of this determinant is equal to 0. So we saw that R1 was nothing but same as R3. So this way this result is 0. Similarly, if two columns C1 or C2 or C3, any of these two are identical, then its value will be 0. We have one sub property, you can say sub property is that if any two rows or any two columns are proportional. Proportional means if we take something common, then those two row or those two columns will become identical, then this property will be applicable. For example, 2 3 5 0 5 6 and 4 6 10. So look at here, 2 3 5 4 6 10. So we take, before that I will tell you that property also, if any constant this multiplication, but I solve it, and then next property that I will explain, if we multiply to any determinant by a constant, then any row or any column will be only multiplied by that constant. So what we are going to do, this, look at here, we can take 2 common from this this R3. This is again a property I told you, but I tell you later. Next, so what will happen, I am taking 2 common from here. So the first row is 2 3 5, second row is 0 5 6, and the third row is 2 3 5. So look at here, this 2 is outside, so these two are again identical. So as using this above property, its value will also be 0, that you need to remember. So if any two row or any two, if any two rows or any two columns are proportional or identical, then its value is 0. Next property, that is property number 4, is what I was talking about. If any determinant is multiplied by a constant, then any of its row or any of its column will be multiplied, not all the elements or not all the rows or not all the columns. So if we multiply any determinant by a constant, then that constant will be multiplied to any one of its rows or columns, but not more than one. What does it mean? I tell you. Suppose we have determinant A is equal to 3 4 5 0 2 0 and -1 5 -3. We want to multiply this determinant by 2. So 2 times determinant A will be equal to, now we have 6 choices. How many choices? 6 choices. Either we can multiply to R1 or to R2 or to R3 or C1, C2 or maybe C3. But out of these 6, only we can multiply one at a time. So that will be demand of the question, that which row or which column should be multiplied. So we simply, you can say R1 will be multiplied or C1 will be multiplied. Let us we are multiplying to C1, so this 2 will enter into C1 only. So 3 2s are 6, 0 into 2 0, minus 2 into 1 minus 2, and then rest will remain same, 5 0 minus 3. Same thing what I was talking about in property number 3 also. Suppose we have any determinant on this 2 4 6 5 10 15 and 3 0 2. So we can take something common from any of the row, any of the column. So in this particular row we have 2 common, so 2 is taken out, From the second row we have 5 common, so 5 is taken out. So now we are writing 2 into 5 out of the determinant, so it will be 1 2 3 first row, and 1 2 3 second row. 5 5 2 is 10, 5 3 is 15, and 3 is 0 2. As you can say, the property, previous property, any two identical, its overall value will be 0, but that we are not going to discuss. I am talking about the constant. 5 2s are 10, and then this 1 1 3 2 2 0 3 3 2. So this is called multiplying or taking common of the constant. Now you need to be little careful here over here, that in matrix we can multiply a matrix with any constant, but all the elements, whether it is 2 by 2, 2 by 3, 3 by 3, any matrix, when we are multiplying any matrix by a constant, then all the elements of the matrix will be multiplied. Or in other case, if we are taking common something from the matrix, then all we should take common from all the elements. We cannot do that any of the row or any of the column. If that is the case, that is the case of determinant only. In case of determinant only, we can take common from any of the row or any of the column, single row only, or we can multiply to the single row or single column only. That is the case of multiplying a determinant by a constant. Next, property 5 is that in any row or column of any determinant, if that row or column is the sum of more than two or more elements, then that particular determinant can be divided into that many determinants depending upon the number of addition or subtraction of the elements. What I mean to say, if in any determinant any row or column is the sum of two or more elements, then that particular determinant can be divided into that many determinants. That many determinants means depending upon the number of elements involved. For example, let us we have determinant this 1 2 3 5 plus x 7 plus y 8 plus z minus 3 0 6. Now in this determinant, this particular row, this particular column number 2 is the sum of two elements in every row. So this determinant can be written as the sum of two determinants. For example, this 1 2 3, then this will be taken with this 5 7 8 first, and then minus 3 0 6, because 1 2 3 and minus 3 0 6 are common with both the cases. Then here we have plus, so we will put plus sign, and then this will be written in the middle of the determinant. So again 1 2 3 1 2 3. Now instead of this that is already taken, we'll write x y z and minus 3 0 6. So this is property number 5, that any of the row or any of the column, if it is a addition or subtraction of more than one element, then that particular determinant can be divided into two or more determinants. Next property number 6 is very important to solve the next exercise. Property is like that. In any determinant, any row oblique column can be written as the sum with the product by a constant to other row or column. What is this? Let us understand it by one example. Let us have a determinant 2, 3, 4, 3 minus 2, 0, 1, 0, 2. Let us evaluate it. It's twice of minus 4, then minus 0, then minus 3, 6, minus 0 and plus 1 into 3, 0 and plus 8. This is equal to minus 8, minus 18 plus 8 is equal to minus 18. Now what is this property that I apply here? Now for example, we multiply this particular column C2 by 2 and we add into this C1, and then C1 will be replaced by this. What I want to say, C1 will be written as C1 plus twice of C2, that is only C1. This elementary operation we have done in matrix. So this determinant will be written as C1 will be written as twice of C2. So first of all, I write this thing as it is 2, 3, 4 and we have written plus. So and then multiply by 2, 3 2s are 6 plus 6, then minus 2 2s are 4 and here plus 0 into 2, 0, and then rest will remain same, 3 minus 2, 0, 1, 0, 2. Now let us solve it. 8 minus 1, 4, 3 minus 2, 0 and 1, 0, 2. Evaluate it. So we get 8 times, leaving this to minus 4 and then minus 0 and then minus 3 and then minus 2, leaving this to minus 2 and then minus 0 and then last plus 1 into minus 0, that is 0 only, and then minus minus plus 8. So 8 into minus 4 minus 3 into minus 2 plus 8 minus 32 plus 6 value. These two are same. These two are same. That means this is the property that if we multiply to any of the row or column by a constant and then we add that row or column into another row or column, then overall the value of the determinant remains unchanged. That value remains same. That means we can do this alteration at any point of time wherever we need. We start exercise 4.2. in which first question, prove the following determinants but without without expansion means by using the properties of determinants. We cannot, means what is this expansion? You understood this word expansion means that you cannot evaluate that by row or by column. You have to use those properties which we just studied, and then using those properties we have to evaluate. We cannot expand. So for that, the question first is given x, y, z and a, b, c, x plus a, y plus b and z plus c is equal to 0. We have to prove it. So taking left hand side, that is obviously determinant. Now using that property, one property we had studied, that the sum of any row of determinant can be divided into two or more determinants. So this determinant can be written as x, y, z, a, b, c, and this x, y, z. First elements we have taken. Now after this is plus, so we put plus, then x, y, z, then a, b, c, and then this is a, b, c. Now we had studied another this thing property where if any two rows or any two columns of any determinants are identical, then the value of that determinant is 0. So using that property, its value is 0 plus its value is equal to 0 right hand side, hence proved. So by using the properties of determinant, we have proved this determinant. We have used here two properties. One is that sum property and another one is identical properties. Then question number 3, 2, 3, 5, 7, 8, 9, 65, 75 and 86 is equal to 0. This we have to prove. So again, taking left hand side is this one. Now we can multiply to any column or any row by a particular constant, and that particular value can be added to another this row or a column, other row. So for this, suppose this is 65. Now just imagine here, if we multiply this 7 by 9, so 7 9 is 63, and adding it to this C1, I am talking about C2. If I am multiplying this C2 by 9 and adding it to this C1, then what is the value? 7 9 is 63, 63 plus 2, 65, then 65. Why we are doing so? Because in that case we will have this row, this column and this column identical, then automatically by using the property we can put the value is equal to 0. Now same constant should be multiplied to all the elements. So 8 9 is 72, 72 plus 3, 75, 9 9 is 81, 81 plus 5, 86. So what we are going to do here, this C2 we are going to change by 9 times C2 plus C1. We are replacing this C2 by doing this operation. So what we are going to do here, C1 doesn't change, so 2 3 5, that is same only, and then C2 in place of C2. Now multiplying 9 by C2, 9 7 is 63 plus 2, 65, then 8 9 is 72 plus 3 is 75, and 9 9 is 81, 81 plus 5, 86. This is C2 and now C3, 65, 75 and then 86. Now look at here, C1 and C2 are C2 and C3 are identical. C2 and C3 are identical. Therefore, its value is equal to 0, is equal to right hand side, as proved. Now the question number 4 is 111 BC CA AB, and the third row is A into B plus C, B into C plus A, and C into A plus B is equal to 0. So we need to solve little and then we will evaluate, not evaluation, we will use properties. So BC, CA and AB. We multiply this inside. So what will happen? AB plus AC, BC plus AB, CA plus CB is equal to 0. Now if we add this C2 into C3, then what will happen? AB plus BC plus CA. Here also AB plus BC plus CA, AB plus. So we will have all the elements same in the C3, then that can be taken common. So what I want to say you, C3 will change with the help of C3 plus C2. This we can do here. So what will happen? 1 1 1. C2 doesn't change, VC CA AB. Now in place of C3 we will write C3 plus C2, AB plus this we will add into this and then that will be written here. So AB plus BC plus CA, AB plus BC plus CA, AB plus BC plus CA. Now we have studied that property also, that any element can be taken common from any row or any column. So now AB plus BC plus CA, this element is common from C3. So taking common AB plus BC plus CA from C3, we get AB plus BC plus CA out of the bracket, and we'll have 1 1 1 here, and the second is BC CA AB, and the last one we have taken this AB plus BC plus C out, so 1 1 1. Now C1 and C3 are identical, therefore its value is equal to 0, is equal to right hand side, hence proved. Question number 5 says, and this question is very important, B plus C, C plus A plus B, Q plus R plus P, and P plus Q, Y plus Z, Z plus X, X plus Y. This we have to prove, is it equal to A, B, C twice of this determinant P, Q, R and X, Y, Z. So it looks very complicated, but while solving and using the properties of determinant, it will be very easy. Now look at here, that this side we are keeping the right hand side as twice of A, B, C. Look at here, so we need A is always there, so we don't need in BC in the first this row, and we need P over here, that means we don't need QR over here, and then similarly we need X here at this point, so we don't need YZ, QR and BC R2 be eliminated from R1. So for what? So you just search where are these found. This B and C are found in row 2 and row 3. So what we can do, we can change R1 with the help of R1 minus R2, because C and C will cancel here, and this B is in R3, so that also will be subtracted. R1 will be written as B plus C minus C minus A minus A minus B. So minus A twice of minus A, and then B and C are cancelled. Similarly, here Q and R are cancelled, so P and P minus 2P, and here we have ZY cancelled, so XX minus 2X. This rest will remain same, C plus A, R plus P, Z plus X, A plus B, P plus Q, and X plus Y. Now look at here, 2 common everywhere, so we will take common. Taking 2 common from R1, we get what we get. 2 is outside, so minus A, minus P, and minus X. Look at here, compare with the right hand side, A plus P plus X, no problem, that can be sorted out later. So we got first row, this AP X of the right hand side. 2 multiple outside, that also we got. And then next is C plus A, R plus P, and Z plus X, A plus B, P plus Q, and X plus Y. Now we need to think over it, how we can get this second row into BQY. So what we are going to do, this, if we subtract this R1, this this R2 subtracted into this R1, then what we get? Let us see. This is minus A, this is plus A, plus A, this is minus P, this is plus P, this is minus X plus X. So instead of subtraction, if we add it, so means if we add these two, then A cancel, P cancel, and then X, and then we will get C, R, and Z, no problem. That is at R3, so we are getting at R2, no problem, that can be adjusted later. So we'll do this R2 will change with the help of R2 plus R1, and similarly we'll go for this also. And this R3, if we are adding into R1, then A cancel, PP cancel, and then XX cancel, so there also BQY will get. So we are doing the same thing. R3 is also going to change with the help of R3 plus R1. These two operations we are going to apply upside. So minus A, minus P, and minus X, no change at all, same only. Now instead of this whole, now we have this operation R2 plus R1. So A cancel, then C, and then PP cancel R, and then XX cancel Z. Similarly for R3 also, A cancel, so we have B, P and P cancel, so we have Q, and X cancel, so we have Y. Now look at here, we don't want C in the middle here at R2, we want at the bottom line, that is third row. So what we are going to change, this these two are going to change. So what we are going to give the next operation, R2 and R3 are going to interchange. So remember that property, when we are changing any two row, any two column, then minus will come out. Minus is coming for changing these two rows. These two rows are interchanging now. So first R1 will remain same, minus A, minus P, minus X, and then here we have B, Q, and Y, and C, R, Z. These two exchanged, because of that this minus went out. Now let us take minus common out of this, so that we are going to write here minus from R1. So that minus and this minus plus, so is equal to twice of APX plus in plus, and BQY, and CRZ. Z. So now compare with the right hand side. ABC, PQR and XYZ is equal to right hand side, hence proved. So that's how we have completed this particular question. मुझे सणो होता था कच कच बिच आई हो आज